Today, we're going to pull back the curtain on the blueprint behind pretty much every complex piece of software you use. It's called object-oriented design. And trust me, it's the architectural magic that keeps the digital world from falling into complete chaos.
I mean, really, stop and think about it for a second. How does your banking app or a social media platform with millions of lines of code get updated constantly, and somehow it just works? How does it not all just crumble into a mess?
Well, for a long time, that's kind of what happened. Back in the day, code was often this tangled, fragile mess. Programmers had a great name for it, spaghetti code. Because, you pull on one noodle and the whole plate of spaghetti moves with it. One tiny little change could set off a chain reaction of errors everywhere. It was an absolute nightmare to fix or update anything.
But then, a completely different idea started to take hold. A new way of thinking that said, let's stop weaving this tangled web and start building with something more organized, something more like digital Lego bricks.
And it all boiled down to this one simple, powerful question. Why are we writing these long, abstract lists of instructions when the real world isn't like that at all? The world is made of things, things that have properties and can do stuff. And that little shift in perspective, that was the beginning of everything.
And at the absolute heart of this whole thing is the object. An object in software is just what it sounds like. It's meant to be a digital mirror of a real-world thing. It's a neat, self-contained little package that bundles together its own data, that's what it is, and its own behaviors, that's what it can do. So a car object would know its color and its current speed, and it would be able to start, stop, and accelerate. It all makes sense, right?
So how do you actually build things this way? Well, it's this really logical two-part process. It's all about figuring out the what and then figuring out the how.
First up, you've got analysis. This is the what phase. You're not writing any code. You just look at the problem you're trying to solve and you identify all the things, all the objects that are involved. Then you move on to design. That's the how phase. This is where you take each of those objects and you sketch out its blueprint. What does it need to know and what can it do?
Let's make this real with a super simple example. A library system. In the analysis phase, what are our objects? Well, we've got a book, a member, and a librarian. Easy enough. Then in the design phase, we start to flesh them out. We decide our book object needs to know its title and its ISBN. And what can it do? Well, it should be able to check availability function. See? We're basically creating a little digital version of a real book.
Now, this might all sound pretty simple, but shifting from just writing instructions to actually defining objects, believe me, the payoff is enormous. It completely changes the game for how software gets built, and more importantly, how it's maintained.
This right here is the core difference. The old traditional way focused on verbs, the actions. You'd have a long list of instructions. Do this, calculate that, print this. But the object-oriented way focuses on the nouns, the things themselves. The actions now belong to the objects, which makes the whole structure of the code look a lot more like the real world it's trying to represent.
And that leads us to the single biggest win. Remember that spaghetti code? The old way was just so fragile. Since the data and the functions were all separate, if you change one little piece of data, you'd have to go on a scavenger hunt to find and rewrite every single function that ever touched it. Ugh. But with object-oriented code, changes are contained. If you need to change how a book works, you only make that change inside the book object. The rest of the system doesn't have to know or care. It's so much more robust.
This table really lays it all out. We've already talked about how the focus shifts from actions to things. But just look at the other benefits that cascade from that one change. The code becomes more robust, you can reuse pieces of it, and it's so much easier to scale up. Let's dig into a couple of the key ideas that make this all possible.
First is a principle with a fancy name, encapsulation. But the idea is really simple. Think about a car's engine. You don't need to know anything about pistons or spark plugs to drive, right? You just use the pedals and the steering wheel. That's encapsulation. It seals away all the complex, messy inner workings of an object, and it only exposes the simple controls you need. This is awesome because it protects the object's important data from being messed with by other parts of the system. It's like a built-in security guard.
The other monster benefit is reusability. I mean, this is a game changer. Once you've spent the time to design a really good wheel object, you don't have to reinvent the wheel every single time. You can use that exact same wheel blueprint for a car, a truck, a bus, whatever. This build once, use everywhere philosophy saves a staggering amount of time, and it keeps everything consistent.
So look, this all sounds like a pretty big deal for developers, right? But why should you, as someone who just uses all this tech, actually care about any of it?
Well, you should care because this way of thinking is what makes our modern digital life even possible. The fact that your phone's operating system is stable, that your banking app is secure, that your favorite video game is so incredibly complex, all of it is manageable because it's built out of these reliable, self-contained, and reusable digital bricks.
And we're not talking about some niche, nerdy concept here. This is the dominant way of building software, period. Something like 90% of all big, modern software projects are built using these exact principles. It's the industry standard for one simple reason. It's the best way we've ever found to manage the incredible complexity of the software that literally runs our world.
So the next time you open an app on your phone, try to look at it a little differently. If you open your music app, can you spot the song object, the playlist object, the user object? Can you see how they all have to work together? See, object-oriented design isn't just about code. It's a way of seeing the digital world. And now, you can see it too.